So we were given the task to look at these two cars, the white car and the FedEx car. And the white car and the FedEx car are moving, and then they have a collision. So before we take any data points or anything, we first need to use a scale. And our scale that was given to us to use was one of the lengths of the side of the sign, which is in the shape of a triangle. And the length of this is 0.915 meters. All right, now that we have a scale, we can finally plot points for our cars. And we're going to start with the white car. So to begin, I decided to plot a point for the left bottom corner of the white car. So each time the frame would move, I would plot a point for the left bottom corner. And it would keep on moving, and then as it hits here, the white car is not visible anymore, so I can no longer plot points. So I continue the next frame until it is visible again, and I continue plotting points until it reaches a stop. Now from those points, we have this data table. And in this data table, there's a column for time, the x in meters, the y in meters, the velocity of the x in meters per second, and the velocity of the y in meters per second. And after about the 10th point here, we can see that a collision has occurred from the Logger Pro video and from the change in the velocity. Okay, so looking at the graphs, we can use, we have plotted these points based on the data table. And from these points, we can use them to find the velocities. And the velocities are simply just the slopes. So we take the first 10 points, since after the 10th point is when the car collided, and we find the slope, which is 3.746 meters per second, or the initial x velocity. Then we find the next points, the final, which is the final x velocity, and it's negative 2.684 meters per second. Then we go to the y data table, and we do the exact same thing. So we take the first 10 points, find the slope, and the velocity is 2.066 meters per second. And then we find the final points, or the final velocity of the y, and we get a slope of 0.02941 meters per second. So now that we have all those velocities, we can write it in an evenly manner. So we can have the initial velocity of the x is 3.746 meters per second. The initial velocity of the y is 2.066 meters per second. The final velocity of the x is negative 2.684 meters per second. And the final velocity of the y is 0.02941 meters per second. So much faster. By using the initial velocity of the x and the initial velocity of the y, we can create a triangle to find the resultant. And to do that, we just plug in these numbers into the Pythagorean theorem of a squared plus b squared equals c squared. And c is about 4.278 meters per second. So that means, and we also need to find the degree, since we need to find the direction. The tan of undefined equals 2.066 over 3.746, and we get the unknown angle to be 28.88 degrees. So that means that the initial velocity is 4.278 meters per second, 28.88 degrees north of east for the white car. All right, now we have to calculate momentum. And the formula for momentum is mass times velocity. So we already calculated our velocity, which was 4.278 meters per second, and then the degree. And then the mass, which was given to us, was 1,485 kilograms. And when you multiply them, you get, for the momentum, 6,352.83 kilograms meters per second, 28.88 degrees north of east. So for the final velocity, we do the same exact thing. We take the final velocity of the x, which is negative 2.684 meters per second. But when you say negative 2.684, that just means it's in the opposite direction, or going west. And the final velocity of the y is 0.02941. And this is not drawn to scale, since 0.02941 is a very small number, and it's very, yeah. And then, so you use the same method again, a squared plus b squared equals c squared, get 2.684, which is almost the exact same thing as the x. You use the inverse tan, get 62.78 degrees, and you get, for your final velocity, 2.684 meters per second, 62.78 degrees north of west. Again, we have to find the momentum. This time, it's for the final momentum of the white car. Again, we take our velocity and multiply it by our mass. So the velocity is 2.684 meters per second, 62.78 degrees north of west, times 1,485 kilograms. So that means our our final momentum of the white car is 3,985.74 kilograms meters per second, 62.78 degrees north of west. So now that we've done all the things for the white car, it's time to move on to the FedEx car. And same thing, we have to plot points for the FedEx car. And I decided to use the right wheel, the right bottom wheel of the FedEx car, as you can see right here. And so as you continue in the video, each time I move the FedEx car, I plot a point for the bottom wheel. And then eventually it stops at around this point. So this is our data table, just like the previous in the white car, just that the numbers are different. And at about the 10th point right here, this is where the collision occurred. So while looking at our graphs, we will need to remember this. So looking at the graphs, just like in the white car, we look at the X in this graph and the Y's in this graph. So going to this part, the car collided just before the just before the 10th point. So at the after the 9th point, I had a collision, and the collision we do not include the point because it may mess up our results. So from this, for the first to the 9th point, we take the slope, which is the velocity, which is equal to 8.041 meters per second, and for the next points, the final velocity, we get negative 0.5889 meters per second. And then doing the same thing for the y, we skip the 10th point, and finding the slope for the initial y velocity, it is 2.343 meters per second, and then the final y velocity is 0.3999 meters per second. So writing these all down in a simple manner, we get all these numbers, but since we've already gone over it, we can move on to the next step. All right, again, we do the same thing as we did for the white car. We plot the initial x and the initial y, and to get the resultant using a squared plus b squared. So we get, and then we use the inverse tan to find the degrees. So we get our initial velocity 8.375 meters per second, 16.25 degrees north of east. And then to find the momentum, we multiply it by its mass, and the mass of the FedEx car is 4,525 kilograms. And then after that, when you solve that, we get the initial momentum is 37,896 kilograms meters per second, 16.25 degrees north of east. So now we move on to the final velocities, and the final x is 0.5889. The final velocity for the y is 0.3999. And again, use a squared plus b squared equals c squared. You get 1.07. Find the degree, 34.18 degrees. So that's the final velocity is 1.07 meters per second, 34.18 degrees north of west. To find the momentum, you multiply it by the mass. And the final momentum of the FedEx car is 4,841 kilograms meters per second, 34.18 degrees north of west. All right, now we need to figure out the total momentum of the white car and the FedEx car. And to do that, we take the initial momentum of both the white car and the FedEx car. The white car is 6,352.83 kilograms meters per second at 28.88 degrees right here. And then the next one, and for the FedEx car, is 37,896.875 kilograms meters per second at 16.25 degrees. So now that we've created these two vectors, we have to draw this dotted line, and this is what we're trying to figure out. And so now that we have this, we need to figure out the angle of this, which is A. So the measure of angle A is equal to 51.12 plus 90 plus 16.25 equals 157.37. So the way we got 51.12 is that we subtracted 28.88 from 51.12. And I drew another line here, and I figured out that this angle and this angle are alternate interior angles, meaning that they are congruent. So this angle is also 51.12 degrees. And I realized that this is 16.25 degrees, and then I drew another dotted line and figured out this is 90 since it's the right angle. So by adding all these 3 degrees, I got the measure of angle A, which is 157.37 degrees. And next thing we have to do now is to find the length of A by using the cosine rule. A squared equals b squared plus c squared minus 2bc cos of A. So we plug in all these numbers for the different values. So B is 37,000 37,896.875, C is 6,352.83, and then the cos of A is 157.37. So when we plug in all the number we get, A is 43,828.812. That means the P total is 43,828 kilograms meter per second, but what's the degree? So we have to figure out the degree. And to do that, we take the sine of A divided by A equals sine of C divided by C. But in this answer, we're trying to figure out the measure of angle C. So we need to isolate C. So what we do is we take the A's to one side and we make it sine of C equals sine of A divided by A times C. That makes it, and then we take away the sine by making it measure of angle C is equal to the inverse sine times the sine of 157.37 divided by 43,828.812 times 37,896.875. And what you get is measure of angle C is about 19.43 degrees. So that means that the total momentum is about 43,828.812 kilograms meters per second, 19.43 degrees north of east. So after we figured out the total momentum, we need to figure out the final momentum of the white car by using vector analysis. So first we take the final momentum of the FedEx car, which is 4,841 kilograms meters per second at 34.18 degrees north of east. So we plot that. And then we plot the total momentum, which is 43,828, 19.43 degrees north of east. And then after that, we combine we find out that this angle right here is 34.18 degrees by using alternate interior angles. And we find out it becomes 53.61 degrees. Next, by using this information, we use the cosine rule. A squared equals b squared plus c squared minus 2bc cos of A. So we plug in these numbers and we figure out that A is 41,140.423, I didn't mention it here, but kilograms and meters per second. And then after that, we have to find the degree. So we use the sine rule. And we put the sine of A is divided by A equals sine B over B. And then we isolate the measure of angle B, and we figure out that the measure of angle B is equal to the inverse sine times the sine of 53.61 divided by 41,140 times 43,828. And we figure out that the measure of angle B is equal to 59.05 degrees north of west, which is not mentioned here, but will be mentioned later. So based on vector analysis, the final momentum of the white car should be 41,140.923 kilograms meters per second, 59.05 degrees north of west. Now this is very far from our original result, and this could be due to different factors, but one possible factor is the fact of that when the person, while driving, they applied brakes. The model that we have currently does not include the factor of brakes in our analysis. Now looking at the weaknesses in this project, I'd say there is quite a few. To begin, one of the weaknesses is that this video is not in an aerial or sky view, which would make it a lot easier, since in this video the car is getting further, and because it's getting further, it's harder to mark and be more accurate in plotting your data points. And not to mention, as you can see, when the FedEx car hits the white car, you can't plot points for the white car since it's blocking its view. Another disadvantage to this project is the fact that it is very hard to redo it precisely, because each time that you try to do it, it's going to be hard to get exactly the same points as you did last time. And this causes a great variation in your results. So taking a look at this video, we want to figure out whose fault it is for this car crash to occur. So if you look carefully to this video, you can see that the white car is in his lane and decides to turn. Okay, so as you can see, this is the fault of the white car, because if you look at the lane here, it clearly states that you can only go straight. And the white car decided to take a turn at this last second, which is technically illegal in some sort. Or if he wanted to turn, he should have turned earlier before doing this because it would have decreased his chances of getting into a car accident. So in conclusion, the white car is guilty.